Hey guys, this is Morga, and for this video, we will learn about finding the equations of tangent and normal line to a curve. I think you guys already know that the derivative of a function can be interpreted as the slope of the tangent to the graph of the function. So for you guys to be able to visualize this more, consider this graph here. Let's draw a curve there, and a straight line there, and a point. And that straight line there, which touches the curve in one point, is called the tangent line. And let's consider this curve here as y as a function of x. And that line there, which forms 90 degrees, is called the normal line, which is perpendicular to the tangent line. And let's consider this point here as p sub 1. Let's remember, guys, that it is important to know first the principles of this topic before jumping to its examples. And that is what we are doing right now, so you guys have to listen on this part carefully, okay? So again, this line right here that touches our curve in a point is, again, our tangent line. It is a line that touches the curve in one point. And this one right here is our normal line, which is perpendicular to our tangent line. Again, the derivative of a function is equal to the slope of the tangent. So it means that if we get the derivative of the function given, we can now get the slope and have our equations of our tangent and normal line. So to find the equation of the tangent is given by the point-slope form of the equation of a straight line in analytic geometry. That is, y minus y sub 1 is equals to m times x minus x sub 1. And that is for our tangent. And since the normal line is perpendicular to the tangent, which shows in our graph there, then its slope is the negative reciprocal of the slope of the tangent. Hence, this is the equation of our normal line. And if you are wondering what m represents, m is our slope, which means that we need first to get the derivative of the given function and substitute all the values of x and y, and then we get our slope. And we will finally have our equations. Are you all guys ready? Because now we will have our first example. And I have something here that will help you guys to remember the steps of finding our equations. So actually, the first step and the second step could be interchanged. Either you will solve the derivation first or the slope of the function. And for a third step, finally, we can have our equation. So now let's start. Let's read first the problem. Find the equation of tangent and normal line to a curve y is equals to 2x over x plus 1 squared at point 0, 0 in slope-intercept form. So again, our first step is the derivation. So let's first derive the given function. So in here, we can use the division rule. First, we derive the numerator and copy the denominator. Minus, derive now the denominator, and then that one, and then copy the numerator all over the denominator squared. That would be it. And then we will expand. Multiply this one here and again all over the denominator, that one. And now let's subtract this one to this one. All over again to the denominator, x plus 1 raised to 4. And now let's divide the numerator and denominator. And that would be it. That would be the derivation of the given function. And second, the slope. We will just input the values of x and y given. So now let's substitute our x and y to get our slope. So now our slope here is 4 divided by 2, and it's equal to 2. That would be our slope. Slope is equals to 2. Now, since we have our slope already, we can finally have our equation for a tangent line. Y minus y sub 1 is equal to m times x minus x sub 1. Y minus our y sub 1, 0, is equals to our m, 2, times the x, or x sub 1, 0. Now let's expand. Y is equals to 2x. And let's see here, it says slope-intercept form. And since it is already a slope-intercept form, this is our final answer for tangent line. We already have our equation for the tangent line. So now for our normal line, y minus y sub 1 is equals to the negative reciprocal of our slope times the x minus x sub 1. Y minus our y sub 1, 0. Our negative reciprocal of our slope, negative 1/2. Times the x, and then the 0 there. And since again it is already a slope-intercept form, it is already in simplest form, so that would be it. This is our tangent line and our normal line. So now let's see again the steps that we have performed. First, the derivation, which we have done. And the second is the finding the slope, which is this one. And for our third one is our equation, which is here. Now I hope that the steps that I've shared with you will be a help. Are you guys still there? Because now we will have our second and last example. Again, here's the 3 steps that I've shared with you guys in our first example. And again, let's read the problem. Find the equation of tangent and normal line to a curve y cubed plus 3xy plus x raised to 4 is equals to 5 at point 1, 1 in general form of a line. So now let's start by doing the first step, which is the derivation of the given function. 3y squared y prime plus 3 quantity of y plus xy prime plus 4x cubed is equals to 0. So 3y squared y prime plus distribute 3y plus 3xy prime at copy 4x cubed is equals to 0. So let's move the variables that don't have a y prime on the other side. Yan. And then factor out y prime. 3y squared plus 3x. Then copy. Then let's divide. That one. Then cancel out. Y prime is equals to negative 4x cubed minus 3y all over 3y squared plus 3x. And for our second step, to get the slope, we have to input the values of x and y. So let's do this. Copy. Then substitute the x and y value. Is equals to negative 4 minus 3 all over 3 plus 3. So it's negative 7 over 6. So negative 7 over 6 is our slope. So now that we have our slope, we can now proceed to our third step, which is do the equation. So first, the tangent line. Y minus y sub 1 is equals to m times x minus x sub 1. And then let's substitute the x and y value and its slope. And now let's expand. Negative 7 over 6x plus 7 over 6 plus 6 over 6. So copy negative 7 over 6x plus 7 plus 6, 13 over 6. And it says here that in general form. So let's multiply this to 6 so that there will be no fraction for in terms of x. 7x plus 6y minus 13 is equals to 0. That would be our equation in general form for our tangent line. And for our normal line, y minus y sub 1 is equals to the negative reciprocal of the slope times x minus x sub 1. And now let's substitute the x and y value and the slope. And now again, expand. Y is equals to 6 over 7x minus 6 over 7 plus 7 over 7. And then perform the operation. 6 over 7x plus 1 over 7. And again, let's multiply it to 7. Cancel 7. Now let's move the 7y on the other side. And now this would be the equation of our normal line. 6x minus 7y plus 1 is equals to 0. Yay! So now let's see again the 3 steps that we have performed in our second example. First, we derive it. Check. Second, the slope. Check. Third, we substitute the slope that we have to get our equation for tangent and normal line. This one and this one. And that's it for our example number 2. Good job, everyone. We solved those 2 problems so easily. Just by doing these 3 steps that we have, we will surely have answers to our problem. So first, derive. Second, the slope. Third, the equation. Again, this is Morga, and if you find this video helpful, please like and comment down below, and please do subscribe and check out for my next video. Adios!